Good afternoon or good morning, depending on where you're coming from. My name is Amy Marks. I'm the head of industrialized construction strategy and evangelism. Thank you so much for joining us here today. We are very happy to be sponsors of this event. And I thought I would tell you a little bit about me. We'll do some level setting, then I'll pass it off to our moderator and our panelists. My job at Autodesk is to inform both the product strategy on industrialized construction and to work with all of our customers who are looking at getting on the journey or furthering their journey in industrialized construction. I've been lucky enough to work all around the world. And if you haven't caught our new series called Industrialized Revolution and the Queen of Prefab, you can get it actually in the link in the handouts today, along with some of the other great panels that we did at Autodesk University. So let's level set on a few things. We have a language problem. We have a really bad language problem in industrialized construction. I hear these words all the time, often used in one sentence. And I always say I'm a simple girl. It's really hard for me to understand what people are talking about if we're all using different language. So hopefully today, if I level set on this language, we'll hear these terms in the right way and not in the way in which they sound a little bit like word salad. So with that, I'll go through a few of them as I talk about industrialized construction and what it means, and we'll make sure that we're all on the same page. So I like to use the overarching principle of industrialized construction. That really means the application of manufacturing techniques in the built environment. Now, I saw a couple of you guys getting on and ladies on that are architects. You are not excluded from the built environment. So it means applying manufacturing techniques to the design, pre-construction, construction, assembly, and operations of these buildings, all within the built environment. Sometimes we've used the words modern methods of construction in the past, even myself, including I have a LinkedIn group that is even called MMC, but every time I use the word modern, it kind of felt like it was old. So quite frankly, I'm at the moment, I think a really great terminology to use is the industrialized construction terminology and applying those manufacturing techniques to the built environment. So just like the house that Toyota built, this is, if you're into lean, this is the house that industrialized construction has built. So let's talk about some of the elements within industrialized construction that we need to level set on. At the foundational level, there are both technology enablers and process enablers. On the technology side, we have things like the Internet of Things. We are looking at more and more autonomous buildings and buildings that actually can give us more and more feedback and pieces and parts that can give us more and more feedback. And you're going to see much more about the Internet of Things really getting into the fabric of our new design and construction across the ecosystem. Big data and analytics, we're a data-driven company at Autodesk, and what we're finding is that most groups are really just looking at process and data about process. We are thinking a lot more about productization and how you can get certainty from the data through level setting on productization. And how do we get certainty of the data? How do we reuse that data? How do we find that it's not just faith that we want to use industrialized construction? It's not just correlation that we can see some, times it works, it doesn't work, but we have causation where we can actually see if you do this, you get that. The cloud, obviously important. We have the Autodesk Construction Cloud. We've moved our products to the cloud for resiliency. Most of you who have just, obviously, we've all been through COVID, have really recognized the benefit of that if you're not able to work on the job site. Then there are process enablers, like on purpose, I'm saying lean manufacturing, not lean construction. Lean construction techniques don't actually get you prefabrication by themselves. In fact, they could preclude you, since most of them are actually trade-centric and not element-centric, thinking about elements in terms of multi-trade or volumetric mods. So I'm working with the Lean Construction Institute on those tools. Building information modeling is very important. Design for manufacturing and assembly. It does not mean prefab. That's the biggest problem in our language. It is the enabling design methodology for ease of manufacturing and ease of assembly. And it's not enough to get people up to the front of the process. We need to enable that through the tech. The prefabrication continuum, advanced building products that reduce drying time, curing time, hot work, and welding, single trade assemblies like pipe spools and electrical whips, multi-trade, that is common sense, I think, when you're talking about pieces and parts that have multiple trades like bathroom pods or racks or risers or skids. And then you have volumetric modules. Volumetric modules are not at the hierarchy. These are all tools in the toolkit. Sometimes volumetric mods are the worst applications. Sometimes they're the best. The same thing for all those things on the continuum. We want to use robotics and automation to build more of these things, and inclusive of additive manufacturing as well. That continuum, think about that as product. I'm going to get back to that at the end of this presentation and talk more about what the new normal is going to look like through productization. With that, I'm going to hand it off to Nadine Post, the editor-at-large Buildings Engineering News Record, to bring to you Taking Modular to the Next Level. Nadine?
Thanks, Amy and Autodesk. And welcome everyone to Taking Modular or Industrialized Construction to the Next Level. Thanks for joining us. I'm Nadine Post, ENR's editor-at-large for Buildings, and obviously today's moderator. And we are going to hear from 3 veterans of modular delivery, and they will share how members of the building sector can capitalize on this type of delivery in all of its shapes and forms. And they will also advise how to avoid the pitfalls of off-site construction. Our presenters are Andre Oldacre, co-founder and managing partner at Aura Development, Troy Piddens, a modular specialist with New Design Architecture, and John Bongiorno, director of the modular division at Axis Construction Corporation. So we have 3 different perspectives who are going to present today: a developer and someone who represents an architecture firm and someone who is a builder. So Andre's role as a founding partner of Aura is to find, evaluate, and prepare deals to be underwritten by lenders and investors. He's instrumental in creating the architectural design and vision for Aura's projects. His specialty is off-market deals that have undervalued development sites. And he also supports the latest technologies for efficient building methods. Troy is a 19-year veteran of modular. His current role with New Design Architecture is leveraging his years of experience to help bridge the gap between traditional design build and factory production. John has over 35 years of business development and management experience specific to modular construction. And with Axis, he has completed numerous buildings. His extensive knowledge of modular delivery has led to long-lasting partnerships with modular manufacturers, architects, suppliers, and contractors throughout the US, Canada, and Europe. Now, before we start today's presentation, here is a brief instructional video on how to use your webinar console.
Welcome to this webinar. Before we begin the presentation, I want to provide you with a few housekeeping items. On your screen, you will see a taskbar with icons. Each icon is assigned to a particular element of today's webinar. Click on the person icon to learn more about today's speakers. Throughout the presentation, you can network with others or submit questions to the speakers in the Q&A and chat box next to the slides. Download resources from the cloud icon. After the webinar is over, please take our survey to tell us how we did. Today's event is being recorded and archived and will be available within 24 hours. For on-demand questions or comments, send us an email by clicking Need Help? Email us. If you experience any technical issues today, please refresh your browser by hitting F5 for PC or Command R for Mac. And now I'm excited to turn it over to today's moderator.
Okay, before we begin, I want to remind you to submit your questions, and later in the program, our presenters will address as many as possible. Today's event is being recorded and archived on enr.com/webinars, so you can share this presentation with your colleagues, or you can view it again. And now, Andre will kick off the presentation.
Thanks, Nadine. Andre Oldacre here of Aura Development, managing partner. The picture you're seeing here was developed by my partner, Robert Allen. It's a $1 billion hospital as he was working at Turner before we started AOR development. So we're going to talk a little bit about the pros and cons, the innovation going on in the industry, which there's lots of, and a few of our modular cases. A little bit about me. Started my career in finance with Morgan Stanley and Credit Suisse, and started buying 3 and 4 family houses here in Brooklyn and Yonkers, and was able to create a nice portfolio while running a media business, and then was seeing great appreciation and decided to strictly focus on real estate development. I took formal training from Cornell and Columbia, and we started AOR. Our value proposition, we are 100% focused on modular building and using all sorts of modular, modern construction techniques, and we need to remain flexible because the industry is changing so quickly. We love to maximize the highest and best uses in creating alternative revenue streams, which we'll see in one of the cases, and using renewable energy and prop tech to reduce our operational costs. The building you're seeing here is a potential project right across the street from the Barclays Center. Now, we're in New York City. A lot of big cities have a lot of the same challenges. They have limited land at high prices. There's very little undeveloped land to build on. So you're usually looking at sites that would be knockdowns and reconstructions. There's skilled labor shortages and obviously overpriced construction costs in the cities. And you're dealing many times with inland and tight spaces to deal with, which makes it more challenging for modular. And you're also dealing with union and prevailing wage. I'll skip over some of these in the interest of time. So some of the pros. Now you'll hear some modular builders say that the price is agnostic, and it depends on a bunch of factors: the amount of automation they have in the factory, the levels of efficiency, the process, their supply chain, the procurement. There's a lot of factors that go into that, and obviously the other big cost would be how far you are from the factory, which transportation costs can start to add up as either trucking or shipping. It can be up to 50% faster as you're doing your building, your design and engineering. You're also, once you have permitting, you can then start building your mods in the factory while site work is going on. And then it's much safer environment where all workers are working in a first or second floor at the greatest. Whereas here's a picture I'm showing of an actual picture from a site where guys are on structural steel with no sort of protection in inclement weather. This day it was actually a slight drizzle. So it is a much safer environment for workers in a controlled environment at 72 degrees air conditioned than to deal with all the weather outside. You have fewer delays, as mentioned, but no weather delays. It can be up to 10 times faster with automation than stick built. That's using very high levels of automation that's coming. And you're just more productive when you're in a weather controlled environment. When people working in 100-degree weather and 30-degree weather are just less optimized. In the modular, it's beautiful thing. It's much less waste. In traditional construction, you have between 20 to 28% and up, whereas in modular construction, you usually have 5% and under. And a lot of the material ends up being recycled. You have less staff because you're using a manufactured approach instead of a building approach, and take advantage of automation and robotics and machinery in an assembly line. Some of the cons, like we talked about before, proximity to your job site and proximity to the factory. There are not enough factories around the country. Right now, modular construction is 4% of the industry, so we have a ways to go. There are factories all over the country, but generally not enough. Curved structures, it's not impossible to do, but it is definitely more difficult to do curved structures and architecturally pleasing structures. And building podiums, they're working on it, but as of now, I have not heard of any factories that can handle podiums. Limited change orders can be both a positive and a negative. The negative is that once all the planning and design is done up front, but once it's done, you're pretty limited in your change orders later on down the process. Well, that reduces cost overruns, which is obviously a great thing that happens very frequently in traditional stick-built staging spaces, especially in tight cities where you have very little space. You can have Department of Transportation issues and challenges with putting down all your scheduling your modules and having enough space to efficiently stack them when it's that time. Financial challenges, lenders are very unfamiliar with it at this point. It's getting better. Fannie Mae and others are working on putting out white papers on lending practices, so it is getting better. But for the most part, they are unfamiliar with the logistics and the draw schedules. With modular, you're usually putting 10 to 20% down, and you're paying the rest at delivery, which is a very, very different model from stick built, which is incremental payments. So, in a city like New York City, you can see we have one of the highest in the country, $375 a square foot, typical average for a build. With modular, we think we can beat that, but some of the, doing it off-site. The labor shortage, 79% of construction and development companies have said that they face labor shortages. So more factories obviously needed in the bigger cities and all over the country. When we talk about innovation in construction, we not only have to talk about on-site, not only in the modular factory. The modular factory, you're usually typically building between 75 and 80% of the work in the factory, and that can include facades, all the interiors, including bathrooms, fixtures, flooring, etc. But then you need to also take into account the on-site construction. A modular builder will always outpace the on-site construction by a lot. You could have a 100,000 square foot building that can be built in a factory, with an efficient factory in 3 months, whereas your site work will take much longer with structural and foundation excavation. So some of the innovations that we're seeing, you have lot analysis software that can easily analyze a site, and you put the parameters in. We'll talk about it a little bit more. Show an example, and it can give you best and highest use of the property. BIM technology is reducing waste and takeoff. Automated framing, you can do in-wall frames much quicker. Internet of Things, sensors allows you for geolocation and keep track of everything in the process all at one point. Heavy autonomous equipment, we're now seeing robots put on heavy equipment, and we'll talk about that a little bit more in a few seconds. Insulated concrete forms, literally foam, and then they pour the concrete within the form, and it's looking to be 30% cheaper and about 20% faster, if I'm not mistaken. Robotics, there's all sorts of robotic automation going on in the industry that's speeding up the cost, reducing mistakes. And then you have concrete cloth, which is a dual side, PVC on one side and basically a very malleable fabric that all you need to do is add water to it, and has loads of applications from temporary homes to, you see, dams and all sorts of, roofing, and there's loads of applications on that. Now, when we talk about doing heavy automation, handmade obviously is a lot more expensive. There's a lot more mistakes, and it can be a lot more precise. This example, you see a Tesla Roadster beats all the metrics, but yet it's less than half the price, and that's very similar with modular. So here is one of the lot analysis softwares. This one is TestFit. You put in all the parameters from acreage, FAR, and it will kick out a layout. And you can also put in, parking garages, retail space, and you put the inputs of how many square feet you want per residential unit, and it will kick out the number of units, the number of beds, all within an hour. Now, this is not to replace your architect of record, but it is a quick way for a developer or a general contractor to evaluate sites quickly and easily, and assist the architect in their process and thinking of the layout. Very, very innovative technology going on. From the autonomous construction, Hitachi, Robo Industries, Built Robotics, Volvo with the HXO line series, they're all players in autonomous heavy machinery. Now, this is being tested in open, closed sites. It obviously needs a lot of testing before we can bring it to tighter situations in big cities, but they are claiming to have very, very efficient. I think it's up to 30% faster, and obviously machines don't take breaks, and operators can operate multiple machines at once using the BIM technology. And if you get breaks from local municipalities, you can run these 24 hours a day, which would cost an arm and a leg, using 2 or 3 shifts using human capital. Over on the right side, the Tesla Semi and the Volvo Vera at the bottom, those are ways in the future that we will be delivering modules. The Tesla has the Convoy system where you need one driver in the front truck, and you can have others automated following behind it, which would greatly reduce cost. Tesla is claiming to bring the cost down to 85 cents per mile for each truck. So it's something that the modular industry will be adopting heavily in say 5 years or so. The Volvo Vero is another option. It does very similar. Using BIM technology, amazing advancement in construction. It has reduced plenty of errors and mistakes and miscommunication between your GC, your developer, your architect. Everybody can see everything on the fly. It's real-time communication. So when a change is made by, say, your architect to fix a zoning issue, everybody sees it, and the GC is now alerted and can make his adjustments and supplies. You address all the issues early in the modeling, and some of the software, even by Autodesk, can detect mistakes. All right, we'll go over a quick one modular case. 112 units. In New York, we have a prevailing wage with some of the affordable projects, so about $100 per carpenter. In the factory, you can get labor much cheaper. We were able to use some creative solutions by doing an automated parking garage, increasing our spaces from 35 to 180, and with flexible mix of spaces between monthly car rental and EV charging. And that increased our NOI by $550 $58,000 up and increase the value of the property by $12 million. And that's it for me. We'll skip over the second section, and I'll pass it off to Troy.
Thank you, Andre. And definitely appreciate the opportunity to present today. I think it's great to have such a vast group of panelists and different perspectives and insight on the industry. So pretty fun group to be part of. Just want to jump in real quick. High-level introduction. Troy Tibbs with New Design Architecture, just outside of Boise, Idaho. Had a very unique introduction, I guess, path to get where I'm at in the architectural space. I started in 2001 with a wood frame modular manufacturer. We specialize primarily in high-volume commercial wood frame, multifamily, and hospitality projects up to 5 stories. And so overseeing the design, engineering, project management, site logistics services really gave me a unique insight into the actual application and manufacturing of the offsite construction process. And so it's really been fun for me over the past couple of years to really pull that forward to the front end design process and really bring an intuitive design process, with the nuts and bolts background. I just want to start, first of all, it's just kind of that level setter, defining modular construction. What is it? As defined by MBI, the process in which a building is constructed offsite under controlled factory conditions using the same materials and designed to the same codes and standards as conventionally built facilities. And I think when we start embracing that modular mindset, I always want to get it out there that really the difficulty in the modular design is addressing the gap between the permit submittal documents and the factory shop drawings. And the next step in that is when we look at the permit submittal documents defining the requirements, the factory shop drawings defining the means and methods. And so it really forces that design team to embrace those means and methods in order to coordinate and execute, that front end design process to support the manufacturer. Often we get asked, when's the right time to engage the modular team? And the sooner the better. We always look at that schematic phase for our ability to get in and really implement a lot of the efficiencies and the feasibility associated with the offsite construction process. We're all very familiar with the benefits of modular construction, and sometimes we kind of get in that illusion that just because I'm going modular, all of a sudden I'm going to benefit from all the efficiencies. And it really takes a very intuitive and a very specific approach to that design application. So rather than just taking a building plan and saying, "Oh, I'll draw squares on it, and boom, we'll call it modular. Let's move forward." We actually want to dissect that in the very early stages. We want to look at efficient grid line layouts, the module parameters, minimize the module types, integrate the modular assemblies in the floor, wall, and ceiling, address the MEP layouts, the Revit model development, factory sequencing, construction scope, installation, so on and so forth. So there's a lot of that intuitive kind of the means and methods that we're embracing that goes into that front-end design process. To help with this, we've developed a modular feasibility scorecard, and this really just allows us to go through and hit the high notes. A lot of times we're using this to convert traditional site-built buildings to modular. Our first task when I say, hey, as designed, this gets a 3 out of 10, but with these modifications, with these changes, we can get up to an 8 out of 10 and really increase the feasibility and the efficiency of that layout to increase the benefits that we get out of the offsite construction process. Always, when I talk about the modular mindset, I want to look at the typical design process, from left to right, the schematic design, the design development, going into CDs, doing the design coordination and coordinating the shop drawings. And with the modular process, I try to reverse engineer that a bit. And if you can get in the mindset of understanding at the factory level what's needed for the shop drawing, even though you may not be producing the shop drawings, you understand the processes and the components and the assemblies needed, you can have a very intuitive front-end design process. So that's where having somebody that has those years of manufacturing experience to be able to pull that institutional knowledge forward really helps with the process quite a bit. And really, I think the biggest realization is from a design perspective, knowing what you're laying down on paper, putting in that model through the BIM development process, you're designing for manufacturing site assembly. And so we want to try to reduce any redundancy, any regurgitation of drawings, and make sure that we're building a model that is prepped and primed to flow directly into that manufacturing process. When we talk about the process of drawing development, there's a few things we want to focus on. We really want to focus on scope delineation. Intuitively, I want to be able to flip through these plans, and I want to know, which portions are built in the factory, and in this case, which portions are being built on site, illustrated by the shaded portion. So we go through building plans, elevations. You're seeing it's very clear, very intuitive which components are going to be built on site on this project. We go into sequencing details. In the expanded discussions, we start talking about there is no such thing as modular IBC, right? So we can't leverage those prescriptive requirements. We have to detail them out to illustrate our means and methods because they may deviate a bit from the prescriptive code requirements. So get a little bit more granular in some of the sequencing and the detailing as we're going through these permit submittal developments. And I think the important takeaway here is just to understand that an experienced modular design team helps bridge the gap between the traditional design process and the factory manufacturing needs. When we look at possible hybrid team solutions, whether you're a design professional new to modular, just maybe it's outside your comfort zone, how do we bring in that knowledge, that institutional knowledge? What am I looking for in a modular design professional? And obviously, if you can find somebody that has the hands-on experience with modular design and factory manufacturing, that doesn't mean working at a factory. I've worked with a lot of great architects who have just engaged and embraced and engulfed themselves in learning. It's an education process, and it's something you can't just dip a toe in. You've got to jump in both feet and really immerse yourself to bring your skill sets and your confidence up to speed. The ability and willingness to document the means and methods throughout your permit submittal documents. Experience with the offsite permitting and inspections. Through the jurisdictional engagement, you're dealing with city jurisdictions. Most states have a state factory-built housing program that oversees the offsite construction process for both plan review and factory inspection. So being able to navigate that, understand which submittal sheets go to each group, be able to drive that forward. A manufacturing mindset through the design development phases. And so really kind of that nuts and bolts approach in the early phases of design is really going to help with the efficiency throughout the later phases of construction, and the ability to provide a list of deliverables to support the scope. That's big for me is, instead of, saying we're going to do this and we're going to do that, we want to have some clear deliverables. We want to have examples. We want to have the confidence that we can take that through that full coordination process. So there's multiple arrangements for kind of a hybrid or a joint partnership engagement. We can do some scope delineation between the traditional factory built versus the site built. We use this matrix in a lot of discussions just to kind of break it down. Who's responsible for schematic design development of the site built, of the factory built? What level of development is each group taking it to? Who owns the primary scope? Who's the support scope? And who owns the Revit model at that point? And it really allows us to build kind of that hybrid approach to team collaboration as we bring additional team members, into the modular industry. My goal is not to hide the information. I want to share it with as many consultants as we can and build the industry and make us stronger, because we're all going to win together by embracing the field of work. So in summary, really pushing to understand what is modular construction? What is the definition? What codes, what requirements, what's the same for traditional site-built construction, and more importantly, what's different throughout the process? Engage and embrace that modular mindset, embrace the means and methods, and explore a partnership approach if you're lacking the skill set and resources to help navigate through your first few projects. I'm going to wrap it up, and I'm going to hand it off to John and let him take us through his next portion of the presentation. Thanks, all.
Yeah, thank you. John Buongiorno here, Axis Construction. Pleasure to be joining everybody today on this. Just real quickly, this is going to take you through a case study of a project we just recently completed, the Good Samaritan Hospital Pediatric Emergency Room addition out in Long Island, in West Islip, Long Island. We'll go through some challenges, the solution, the process, and then if time allows, a couple other projects quickly. So again, Axis Construction, we are a general contractor, CM, located in Long Island, New York, doing work throughout the Northeast, but then I've also done projects throughout the country as well. So we've done everything pretty much but residential when it comes to off-site construction. We do specialize in healthcare, but we've done schools, daycares, office buildings, just about everything, like I said, other than residential at this point. So this is roughly an 8,600 square foot addition that we put on to Good Samaritan Hospital, a pediatric ED. Challenges. This was a pre-COVID project that we were awarded with the hospital. So, but there was schedule urgency. Good Samaritan sees over 20,000 pediatric cases in their ED per year, and they felt that it was time to create a dedicated pediatric wing for these children and families to come in to try and ease the anxiety that comes with, trauma. So schedule was important. Constrained site, uninterrupted operations of the hospital, and then just as we were getting into the project on site, COVID hit. Again, this facility is the only certified level 2 pediatric trauma center on the South Shore of Long Island. And again, it sees over 20,000 kids per year in their ED. Ultimately, we were able to speed up the schedule by over 3 weeks, even within dealing with the pandemic that came across us. So the hospital itself is a constrained site. It's limited. It's a small hospital on the South Shore of Long Island. Limited space, as you can see. Small footprint of a hospital. We had a high school, 2 high schools next door, residential. So was not the easiest location. Certainly not a lot of room to work with. So laydown area turned out to be important. They wanted uninterrupted operations. This addition was being added on, in effect, attached to the existing emergency room, and they could not and did not want to stop, obviously, those operations. And again, this was pre-COVID that the design was happening, and then certainly COVID hits, and then we had a whole new set of challenges on site. We broke ground on this project, started foundation work right at the beginning of March, and we all know what happened by the middle of March. That's when things really took off here in New York. So we had some challenges up front with the site. Unfortunately, some workers on site testing positive early on. So having to deal with that, shut the site down, for a week or two, and then get back going. So we dealt with that, threw us a curveball, but you have to deal, with these things. The building was being fabricated off site, so that was helping with that until Pennsylvania decided that all companies were, going to shut down, and the factory that we happen to be using on this project is located in PA, so they had to shut down for a period of time. And then working together, we were able to get through some solutions of getting the lawmakers in Pennsylvania, getting some letters from here in New York to deem the project essential, and the factory was able to start up working on just this project again to finish their piece of it. So, prior to the first two presenters here, Andre and Troy, spoke great about, the benefits of modular here and, how this accelerates the schedule. What we were able to do on this project, we started fabrication of the modules in the 3rd week of December of 19, and we delivered these modules in the middle of April of 20. And then once we set the building, about 90 days later, we were able to turn over the building, had our full DOH inspections or C of O, and they were able to start getting patients in by the 4th of July. Would never have been able to do that utilizing conventional construction. So we were originally scheduled to turn the project over towards more August. And again, we were able to get this done 4th of July. And you can see the schedule savings there. Now, one of the key things that Troy touched on in his presentation was you see those design decisions, that green bar. I always like to highlight this is off-site construction, modular construction is accelerated. Everybody agrees that you have accelerated schedules. It requires, though, accelerated decision-making up front. So some of the decisions that you can put off down the road in conventional construction, it does need to happen up front. So that's why I always try to highlight that. So remember, accelerated construction means accelerated decision-making. Cost certainty, huge. When it comes to off-site construction, being that the largest piece of the project is typically, off-site, your cost controls are there, and it's something really to take a look at. 9 times out of 10, when we're looking at a project, we put 0 contingency on the piece that's coming out of the factory because, again, we're very comfortable with what we're going to be getting. We're comfortable with how we're putting it together when it gets onto the site. So that cost certainty is there, and those savings do get passed along to the client. Most of the time we use a build together system, meaning that the project is built as the building out at the factory, dismantled, shipped, put back together. I don't want to run out of time here. So again, you can see the laid out area. So once we get the modules in, the first 4 days, we did need that parking lot down below there, but then we were able to turn that back over to the hospital and the workers. We were able to turn back over approximately 165 parking spots, and this confined ourselves to the upper area where you see the modular impact area. And again, a lot of that is because you don't have as many workers on site, you don't have as many deliveries coming in, so the disruption to the campus is minimal. We'll move on here. So again, this is just a couple quick pictures of what took place. So we bring the buildings out at a very high level of completion out of the factory. You can see the automatic doors, ceilings, med gases. On this particular case, a precast thin brick system was installed in the factory. And again, quality is key. When you're working within these factories, 35 out of the 50 states have programs that monitor modular construction. And everything revolves around inspections, code, compliance, quality control. So things in the factory tend to really come out at a very high level of completion and a very high level of quality. All things that you definitely want to consider when you're looking at projects. The process, Troy pointed this out himself. You have to commit to the concept, team selection, pre and post design. It's so important early on to commit to the concept. You don't want to have to redo things. If you're knee deep in a project and you want to flip it to offsite, you can, but understand that there might be some costs associated with that to redesign things. So the earlier you commit to it, the better chance you have of capturing all the inherent benefits of the offsite construction. And that's where the cost savings will come in, and then the time especially. Team, certainly do what Troy was indicating. Try and find folks that have done it before, whether it be GC, CM, architect, factory. The entire team, the more experience you can get, the better you are. Conduct interviews. Go look at projects. Visit the factories. See the work that they've done. Educate yourselves on what you're looking to do, and then put a good team together early on. Pre-design. You want to look at the project, make sure that it lays out properly for modular. You have, like I said, 35 out of the 50 states have modular programs. Be familiar with that. How to get those projects submitted to the various states for approval. In New York, not only does New York State have a program, but then New York City has its own regulations that you have to file past what the state looks for. So you want to be careful with, what a particular municipality may or may not have. BIM modeling, very important. There's not a lot of room to work with in the ceiling cavities and within modular. So laying this all out and having everything worked out in advance, making sure you can fit everything up in the ceiling cavity, laid out properly. The Good Sam project, we had, med gases, we had hot and cold water, sprinkler lines, your electric, we had a pneumatic prescription delivery system that was tied into the main pharmacy within the hospital. All of those things needed to fit up in a limited cavity because you just can't transport these things at 15, 17 foot. You're limited. You're trying to ship modules at 14.6 or less. So you want to use BIM and make sure that that's done. All your inspections, you're going to get those. Most third-party inspections are required by the various states, municipalities. So you want to familiarize yourself with that and make sure that the factory that you're dealing with is familiar with that. There's different agencies that are going to have jurisdiction. Get familiar with that. On this project, not only did we have New York State, but we had DOH. We were following the FGI guidelines as with the healthcare building, Article 28. So there's a lot to go through and make sure that you're capturing. Again, the factory that we primarily use on our custom buildings, again, we do a lot of custom work, not a lot of cookie cutter. We do utilize a build together system. This happens to be a 2-story that we were doing, where you can see in the infancy stage of it, starting to lay the modules out and build it as a building within the plant. We then finish it, dismantle it, ship it, basically put it back together. This happens to be a 3-story project that we did, a dormitory out here in Long Island for Malloy College. We were able to actually do it as a 3-story, built the entire structure within the factory. Again, dismantled it, took it apart. That project was roughly about 27,000, 28,000 square feet. But again, we were able to do that all in the plant. So again, quality, the tolerances are there, goes back together really nicely. Again, you dismantle, you want to look at transportation. Where is the building going to? Make sure logistically you've worked all of that out with your permitting, your codes, things of that nature. Ultimately, you get it to the site, you set it, and then look to finish the product. And again, with Good Sam, we were able to, from the time we set the modules to, again, putting them in, it was 11 weeks. So we were able to speed that up. This is a quick video.
This is Dave Cooper, and we are at Good Samaritan Hospital in West Islip, New York. And right now I am standing inside a modular, roughly 7,000 square foot, modular pediatric emergency room addition that we did for the hospital. And Joe Loiacano, you were the one from ground zero that was part of this entire planning process and helped make the decision that offsite modular was the way you're going to go.
As with many other hospitals, particularly in highly populated areas, space and land is always a problem. John Bongiorno came and introduced me to this notion of a modular construction, whereby we could reduce the laydown area for the project and speed up the construction, thereby reducing the amount of disruption. We started, I think we broke ground in around March or February or something. And here it is in June, and the building's up, and we're ready to see patients next week. We were able to construct the foundation and do all of the site work at the same time that you guys were building the building. Even more impressive than how fast we were able to finish the project by doing this kind of simultaneous construction was the fact that we got hit with a pandemic through the entire process, we didn't miss a beat.
The COVID pandemic actually sped up this process,
Right.
And really pushed us as we saw a need to have dedicated space, private rooms for our patients.
Right.
And the fact that this was modular construction obviously was great, not only for us on campus here, but for the entire community, because there was a lot less disruption.
This is really an eye-opener, how this can go. I mean, this thing came complete. You had the walls primed and the oxygen outlets in and the doors hung and everything was taped shut, and it was really quite incredible.
Even the pneumatic tubes were in for the pharmacy feeds,
All
right?
you had to do was connect it.
Everyone that walks into it and walks through is pretty amazed. You know, if we didn't tell people it was modular, there's no way anybody would be able to tell.
Okay, so the reason why I like to try and end with that video, Joe Loiacano there, while yes, he knows of Axis and we've done work with him conventionally, this was their first modular project. And that interview that he did there was totally unscripted. It was his feelings, and it just summarizes and captures everything that we try to do in the modular industry, which is bring cost certainty, schedule acceleration, quality, and he captured it all there. So that's why we show that little process there, and you saw the detail that comes out of the factory and then ultimately is put together on site. A couple other projects that we've completed, two-story building out in Staten Island for New York City Health and Hospitals. That was a healthcare facility that we did for them. That we were able to do 9 months ahead of what a conventional construction was tapped out to be. Another one that we did for New York City Health and Hospitals, a 13,000 square foot outpatient clinic in Coney Island. This was a replacement for a building wiped out in Sandy. And then that dormitory that you saw in the factory, three-story building out at Malloy College, a 30,000 square foot building. Again, we were able to complete that in roughly 25 weeks, which allowed them to put about 103 additional tuitions in their coffers, a full school year ahead of time. So again, we specialize in, and you see, I wanted to give the perspective of custom modular buildings. So the industry can do everything from repetitive hotel type structures to apartment buildings. But if you have custom needs, as complicated as healthcare, the industry can support you and is looking to support everybody. With that, I think I'm out of time, and I'll turn it back over to Nadine to pick it up from here. Thank you.
And thank you, and thank all three of you for your sharing your advice and best practices. Before we have time for a couple questions, I wanted to remind the viewers that we'd like your feedback in our webinar survey to help improve our programs. The survey is available on your screen now or can be filled out at the conclusion of the webinar. And now for our first question. What insurance is carried for product liability and losses during the time that the modules are in transit from the factory to the site? Who would like to take that? Just jump in because we're kind of short on time for questions.
So I can jump in. This is John. So what happens is the transport company that we hire, they pick up the insurances on those modules for the value of the module and the replacement of it, you know, God forbid if something was to happen to it in transit. I've been very lucky throughout my years, 35 plus, where in all of the projects I've delivered, hundreds, thousands of modules, only one has ever had to be rebuilt and replaced. So consider myself lucky. But the transporter picks up those insurances.
Okay, thank you. So are there any modular construction contracts available for newcomers to this?
I'm not sure I understand the question, but
sure,
AIA
I think you could
just...
Yes. Model contracts for others to follow.
Yeah, I know AIA
on that one.
just recently
Yep.
released a document, a contract for modular construction.
Oh, okay. Model contract. Okay, great.
I would point people to modular.org, MBI. Also, you'd probably find some resources there as well.
Right. MBI is the Modular Building Institute? Correct?
Yes.
Yes, and it's modular.org.
So in anybody's experience, is there general contractor pushback because they perceive that modular reduces their scope and revenue and profit?
Well, from a developer standpoint, well, we demand that, so they really have no choice.
Yeah, and I'll take it from
that's in
the
our
GC
RFP
perspective.
and our scope of work.
Yeah, I mean, as a general contractor myself, quite honestly, the modular projects that we do actually have a higher profit margin than the conventional projects that we do. So we look to do as many of them as possible, using offsite construction.
Okay. This is our last question. Is there a building size threshold to make modular make sense? Certain number of units or?
No, I would say no. We've built everything from single family homes to, in progress. You can go, the largest in the world from what I know is 44 stories in the UK. So you have everything from hospital to hospitality, hotels. Marriott's doing a 26-story in Manhattan. The Citizen Barrowries have been built in Manhattan and I think LA and a few other places. But there are tons of single-family homes, companies that are doing wood, and you're seeing the full gamut of construction through modular.
Okay, thank you. And that's all the time we have for questions, but if any of the viewers have any additional questions or comments, please click the email us button on the console, and those questions will be shared with the presenters so they can respond to you directly. Also, as a reminder, you can visit enr.com/webinars for the archive of this presentation, as well as information about upcoming events. Make sure to tune back in for tomorrow's webinar if you're interested in the imperative to adapt, technological disruptions impact on the construction industry, airing at 2 p.m. Eastern Time. And now back to Amy from Autodesk Construction Cloud.
Thank you so much. I think we were focusing on volumetric modular construction today. Some of the things we're talking about at Autodesk are what does the world look like when we move towards more of those pieces and parts on the continuum, and not just volumetric modular. What does prefabrication done off-site look like? And now you even have prefabrication done on-site, so let's be careful of our language. And I think there are going to be some new roles, new business models in the new possible. What's going to happen? You will see much less siloed business models. You're going to see a lot of these vertical integrators coming about, customers as well as general contractors and architects, all vertically integrating with fab, inclusive of super subs, moving up in the supply chain, serial owners that want consistency. We're seeing the majority of prefabrication done right now in those places where there's heavy MEP integration of pieces and parts in manufacturing, hospitals, data centers. That's the place that you see behind the walls, underground, central utility plants, those places where really the prefabrication, the most money is being spent these days. The future state looks very different. You're going to see a lot of different business models. And at Autodesk, we are really working to provide a platform to integrate all the stakeholders and our portfolio of products as well as others to make this easier for you. That's really our goal. We want to make design for manufacturing and prefabrication easier. We want to connect the Autodesk platform with this industrialized construction ecosystem, creating a more collaborative community. And a lot of times today, I heard people say, like, get these people up to the front of the process. I'm 49, I always say. I'm tired of getting to the front of the process and getting people up to the front of the process as the only solution. We need to productize and get that into tech to allow for machine learning and AI and generative design and things like digital twin to help guide our choices. We really need to productize and get out of this ad hoc, repeatable modularization mode. We have to get into the product mindset so we can get things defined, managed, and optimized to truly, truly break through. That is the only way we are going to see certainty and efficiencies. As we know in the new normal McKinsey report, they're talking about 45% of all of the processes moving towards industrialized construction. That's really important. Productization and an enabled platform is going to bring us there. It's not just about people. It's going to be about tech. It's going to be about sustainability and productivity. And so if you'd like to get in touch with me, I'm on pretty much every platform. If you haven't seen the mini-series Queen of Prefab, Industrialized Revolution, or my Industrialized Construction Plenary at Autodesk University, look in your handouts. All of our shows at Autodesk for the university, Autodesk University, are in there, as well as the Queen of Prefab. Contact me. I'm happy to touch base with you guys. And again, thank you so much for letting Autodesk sponsor this, and we look forward to seeing you on your journey for industrialized construction, including volumetric modules. Thanks so much, guys.